Alright, welcome to day 8 of our Unit 13 Probability Notes for Algebra 2R. Today's focus is going to be on the normal distribution and something called z-scores. So first of all, when data is roughly symmetrical, like a single mound shape, we call that data roughly normal, which I discussed yesterday with my students when we discussed shape, center, and spread. So that was on this page. Like this was a normal distribution. So below are distributions describing real-world data. This guy, because he looks approximately symmetrical, is our approximately normal distribution. We always write approximately normal because nothing in life is perfectly normal or symmetrical. That actually sounded pretty deep saying that, but yeah, we write approximately normal. Now this guy, if you draw a nice smooth curve over the top, in general, looks like you have a mound over to the left, but the tail of your data is on the right, and that is a skew or skewed right distribution. Next guy, draw a curve. Looks like your tail is on the left, so this is a skewed left distribution. And then lastly, this guy, SAT scores in 2010. This looks approximately normal. So that's just describing our shape of our distributions. When real-world data is described as roughly normal, the data is dispersed like the diagram below. And what that means is we can expect, I have a highlighter, that if this is our mean, so this is the center of your distribution or your balancing point, you will find that 68% of the data is within one standard deviation of the mean. So that's one standard deviation above and one below. 95% of our data will fall between two standard deviations of the mean. And then lastly, approximately 99% will fall within 3 standard deviations of the mean. So again, the mean is just the middle at 0 there. So these data values are 68, 95, and 99. And this is something called the empirical rule. I'll never test you on specifically that name, but that's technically what this is called with a normal distribution. So on the next page, again, this is the same picture, pretty much the same, and you are seeing what's called a standard normal distribution. A standard normal distribution just means the mean of our distribution is 0 and the standard deviation is 1. Each of these values down below is something called a z-score, which z-score is just a fancy way of saying how many standard deviations you are above or below the mean. Now, real-world data typically doesn't have a mean of 0 and a standard deviation of 1, but we can take our real-world data and convert it to a standard normal as a means for comparison. So for instance, you could have an approximately normal distribution where it looks like the mean is 100 and the standard deviation appears to be 10. And then we can transform that to z-scores by saying, okay, well then this would be 0 and your standard deviation is 1. So again, standard normal just means that you have a mean of 0 and a standard deviation of 1. Now, when we convert our real-world data to a standard normal, the values on the curve are known as z-scores, as I mentioned up above. So these values of -2, -1, 0, 1, 2 are z-scores. This just tells you how many standard deviations that data value is above or below the mean. So it's super easy. If you have a +1 as a z-score, that means you are 1 standard deviation above the mean. If you have a negative, that means it's below the mean. So like a -1 or a -2 is below the mean. So let's put this into practice. Mr. Matt's Calculus 101 class at Niagara University, the results on his final exam are approximately normal. The average on the exam was an 88 with a standard deviation of 3%. We're going to draw and label a normal curve with the data described above. So I'm just going to draw this nice little bell curve. Draw like a number line. Now that mean of 88 goes right in the middle. And then I'm going to draw just a couple on either side of this. Actually, 3 will do. So 1, 2, 3, 1, 2, 3. So if our standard deviation is 3, that means one standard deviation above would be 88 plus 3, which is a 91. Then a 94, then a 97. And then I'll do the same thing in the other direction. So subtract 3, subtract 3, subtract 3. So again, this is your mean, this is your center. The standard deviation is 3. So that's all I'm doing is adding or subtracting 3 from either side of that mean. Now, if your data was then in a standard normal curve, again, would just mean that the center is 0 and the standard deviation is 1. So 1 standard deviation above, 1 below, and that's your standard normal curve. All right, so let's say that Amanda scored an 82% on the exam. What is her z-score? So if I go to my normal curve from the data, here's 82. Now compare that to your standard normal. That's the same location, right? Because that's 2 jumps to the left. That means her z-score is a -2 because she performed 2 standard deviations below the mean. Amanda's friend Jim tells her that that his score put him at a z-score of 1 because yes, this is how we talk about our scores. Well, maybe now we will. So if his z-score is 1, that means he's here. Compare that to your other data, that's 1 skip to the right of your mean. So that means he scored a 91. And that's just going back and forth between our standard normal and interpreting that in a z-score. So again, z-score is just how many standard deviations you are above or below the mean. Because Amanda was below the mean, we had the -2. Jim was above, which is why he had a +1 as a z-score. Now, in order to convert your real-world data into z-scores, we can use this formula. It's your score minus whatever the mean is divided by the standard deviation, which makes sense because it's your difference from the mean divided by the standard deviations to figure out how far you are above or below. So on the SAT, the scores were roughly normally distributed. The mean math score was 515 with the standard deviation of 30. Bridget scored a 430. What is the z-score for Bridget's math score? So her z-score is always your score minus the mean divided by the standard deviation. So her score was a 470. The mean was a 515. Standard deviation is 30. So if I take the difference, divide by 30, I'll save you some time here, you'd end up at -1.5. Now what that means is she scored 1.5 standard deviations below the mean because of that negative. All right, a normally distributed set of data has a mean of 140 and a standard deviation of 12. A data value has a z-score of 2.7. What is the data value? Okay, so just plugging in the info again. Z-score equals your score minus the mean, which typically in these problems, mean is just like a Greek m, so let's write m for right now, over your standard deviation. Okay, they're telling you that the standard deviation is 2.7. We don't know the score. I'm just going to call that x. We know the mean is 140, and the standard deviation is 12. So guys, from there, you're just cross multiplying to solve. So 12 times 2.7 would give me 32.4. Add over the 140, and that's where we'd end up with 172.4 as the z-score. Or excuse me, as the actual score. So 172.4 would give you a z-score of 2.7. So 2.7 standard deviations above the mean. That makes sense because 172.4 is above the mean of 140. Okay, the average price of homes in Western New York is approximately normal. The mean price of homes in Western New York is $400,000 with a standard deviation of $50,000. If Cheryl buys a home in Western New York for $470,000, calculate her z-score. Okay, her z-score is her score, so what she paid, minus the mean, divided by the standard deviation. Let's take a moment and figure that out. And you guys should get 1.4. So her house's price was 1.4 standard deviations above the mean. Now, z-scores are really helpful when we're trying to compare data. So, private colleges tend to cost more than public colleges. Here's a summary statistics for the amount of college debt that undergraduate students are from a 4-year institution in one region. Assume this data is approximately normal. Okay, so we've got our private school, mean is $24,000 in debt with a standard deviation of 16,000, right? And then public, $18,000 in debt with a standard deviation of 15,000. All right, so Nicholas graduated from a private institution and Nathan graduated from a public institution. Each had $35,000 of college debt. Relative to their institution type, who graduated with more debt? All right, let's start with Nick because Nick was private. All right, so he graduated with $35,000 in debt. That's from a mean, or difference of a mean, of 24,000. Take that, divide by 16,000, and that will give me his z-score. So take a moment, figure that out. This is what I got. Okay, so about 0.6 standard deviations above the mean. And then we'll do the same thing with Nathan, who went to a public college. All right, so again, he also has $35,000 in debt. That's a difference from 18,000 divided by our standard deviation of 15,000. Okay, so his z-score should be 1.13 repeating. Okay, so by calculating the z-scores, that helped me more easily compare how Nick and Nathan did relative to the mean debt that they should have coming from their universities. So who graduated with more debt relatively? Nathan actually did. And that's because his debt was 1.13 standard deviations above the mean, as opposed to Nick, who is only 0.6875 standard deviations above the mean. All right, we have one more question to go through. Two versions of a standardized test are given, an April version and a May version. The statistics for the April version show a mean score of 480 and a standard deviation of 24. The statistics for a May version show a mean of 510 and a standard deviation of 20. Assume the scores are normally distributed. Joanne took the April version, so I'm just making a note here. She took the version I highlighted in yellow and scored a 510. Maria took the May version. What must Maria score in order to claim she scored as well as Joanne? So again, this is all about comparing her z-scores. So let's start with Joanne. She got a 510. Now on her test, there was a mean of 480 and a standard deviation of 24. So take a moment and figure out her z-score. You should get 1.25. So she scored 1.25 standard deviations above the mean. Now, Maria took the May version. We don't know what she got, but we want her to match how Joanne did. So that means we also want Maria to have a standard deviation, or excuse me, a z-score of 1.25 standard deviations above the mean. So again, we don't know her score, but we know the mean of the test she took was a 510, and the standard deviation was a 20. So if I put that over 1 and cross multiply, that would give me 25 equals x minus 510. Add over the 510, and that would be 535. So that means Maria must score a 535 in order to claim she scored as well as Joanne because of the z-score that you're trying to match. And that's how we use z-scores to compare data.